Okay, so uh, this section we will talking about projectile motion. So we have seen various types of motions in our previous sessions. No, we also know that what happens to objects thrown into space. So now in this section we will be discussing projectile motion in other concepts like the time of flight formula, horizontal range, maximum height of projectile, and the equation of trajectory. Okay, so before we discuss projectile motion, no? So we will define first what is projectile. So a projectile, that is any object thrown into space upon which the only acting force is gravity. So the only acting force for that is gravity. No? So the primary force acting on a projectile uh, is gravity. So this doesn't necessarily mean that other forces do not act on it. So just that their effect is minimal. So na may mga kuan po, mga air, just like for example, no, mga air resistance. So ato na siya i-kuan, neglect na lang, no, for our ideal nga pag uh, pag-analyze pag-analyze sa ato projectile motion. So just that their effect is minimal compared to gravity. So the path followed by a projectile is known as trajectory. So a baseball bat or thrown is an example of the projectile. Okay. So projectile motion of an object is simple to analyze if we make two assumptions. Okay, so first is the free fall acceleration is constant over the range of motion is directed downward. And secondly is the effect of air resistance is negligible. So when a particle is thrown obliquely near the Earth's surface, it moves along a curved path here, no? Just like for example here. So under constant acceleration directed towards the center of the Earth, so we assume that the particle remains all close to the Earth's surface. So the path such particle is called projectile, and the motion is called projectile motion. Okay, so with this assumption, we find that the path of a projectile, which we call its trajectory, so it is always a parabola as shown in this figure. No? So yung pathway na create na shape is just like a parabola. No? Okay. So in this section, it can be analyzed as a combination of two independent motion in the x and y direction with acceleration ex and ey. So projectile motion can also be handled in this way. So with an acceleration ex that is equal to 0 in the x direction and a constant acceleration ay, which we have the negative gravity, no, in the y direction. So the particle under constant velocity in the horizontal direction, we have this equation from the three kinematic tools of equations. Okay, so x final, that is equals to x initial plus the velocity initial at x direction times our time. And the particle under constant acceleration in the vertical direction, we have also this equation of y final, that is equal to y initial. So our y here is, that is our distance, no, na gitrabelan for our particle at y directions, plus the velocity initial times time minus 1/2 gt squared. Or it could be used this another equation from the three tool kinematic equations, So that is vyf squared equal to vyi squared minus 2g times the difference of the distance final and the distance initial. So it will be used this tool, no, na equation. So let us derive or formulate the horizontal range and the maximum height of our projectile. So assume a projectile is launched from the origin at t initial is equal to 0 with a positive velocity initial component returns to the same horizontal level. So just like for example from uh, our illustration, no? So from point to point here, so let us say we have this particle, no, na launch and niland siya at point B. So at what distance, no, ayan giland. So that is for our range. Okay? And for the measurement of our maximum height, so that is our velocity here is like equal to 0 siya, no? So there's no motion at an instant time lang, no? But after that, so na po motion nga may tabo nga mo travel because of its gravity, due to its gravity, the effect of our gravity acceleration, no? So na motion uh, at this point here, ari ra nga point ang walay velocity. So unsay measurement nato ana or the maximum height nato ana nga iyang velocity at y direction is equal to 0. Okay? So from three kinematic tools of equations, uh, we have this equation, no, nga gi-mention nato before. So by final squared minus by initial squared minus 2g, the difference of the final distance at y direction minus the initial distance at y directions. So since so ato ang pag-analyze from this point to point here, no? So since this is our final na case, final na uh, final nga point, no? So since our velocity here is equal to 0 man, so atong velocity y final here is 0 from this equation. Okay, so ang nabili na lang is kaning byi. So in terms of y direction man, so kung ato ning if we trying to create some right triangle here, so kung kuhaon nato ang velocity yi, so that is from trigonometric function nato, that is vi sine theta, no, sine theta I. So opposite over here, opposite over hypotenuse. So we have vi sine theta squared minus 2g, where atong this one, our y initial here is 0, then but our y final is equal to h. Okay, so our maximum height. So 0 is equals to vi sine theta I squared minus 2g, or that is equal to our h is equals to velocity initial squared sine theta I squared over 2g. So that is for our maximum height of projectile. So what about for horizontal range? So how can we derive that or formulate? So we know that our velocity, no, we have distance over time, di ba? So horizontal range, so we know that horizontal range is in terms of x direction, di ba? Ang pag-locate nato sa yang range, okay? So now our orientation for velocity is in terms of x direction, okay? So we can say here that if we trying to create some right triangle, so atong orientation here is in terms of adjacent side of this right triangle, no? Kung ato mag-create a right triangle here. So that is bi cosine theta, no? So bi cosine theta, that is equal to distance. So our distance here is our range. Okay? So now times r is equals to vi cosine theta times twice of our time a. So asa man natong time a dire. So at point A na dire. So since gineglect man natong other just like for example air resistance, so kung unsay time niya nga na naabot siya dire at point A, mao pod ang time niya from point A to point B. Mo na nga gitwice iyahang time. So from this point to this point, so atong time ana is twice of the time A. So mo na siya nga ay mo siya 2TA. Okay? So from this equation or from our three kinematic tools of equation, velocity final minus velocity y initial that is equal to 0. 0, yes. So from this point, no, yung velocity, we assume this that is equal to 0 kay niland naman siya, di ba? Yung particles 0, and our in terms of y, bi sine theta, yung velocity component minus g, gravity, times that time a. Okay? Oh, no. This one dahil no is from here to here dahil nga point. So mao na nga time a ra yung gibuton din. Time a. So now in terms of time a, no, kani nga equation, we have this equation vi sine theta I over g. So r is equals to vi cosine theta I twice of time a, that is vi sine theta over g. Okay? So now we have this we came up this equation, no, vi squared. So gi-multiply lang nato, nahimo siya squared, then 2 cosine theta times sine theta over g. Okay? So we know that the trigonometric identities for 2 cosine theta and sine times the product of sine theta is equal to our sine 2 theta. So we have this simplified equation for the range, for calculating the range, horizontal range. So r is equals to vi squared sine 2 theta over g. So yan. So that is for our formula for horizontal range. Okay? So what about if you trying to calculate at any point, no, from this projectile path, no, let us say we have this point nga inyo i-calculate. So how we will came up from that equation, we from the three kinematic tools equation nato. So we have here equation yf is equals to y final is equals to y initial plus vi byi times time minus 1/2 gt squared. Okay? So now, from here, initial na y nato or distance y is equal to 0. And for byi, so that is vi sine theta I times t minus 1/2 gt squared. Okay? So now, vi cosine theta for the in terms of x direction, that is equal to x. So x atong gilocate ani is kaniman, di ba? So we have the velocity equals to distance over time. So our distance here at any point is equal to x over the time. So time here is equals to x over vi cos theta I. So now, substitute the time from this equation. That is, we have this vyt, no? So that is vi sine theta I, x over vi cosine theta I minus 1 half g. So our t squared here is x over vi cosine theta I squared. Okay? So now, we can cancel out for this velocity initial. So, naibili na lang. So, our trigonometric function for sine theta over cosine theta is equal to tan theta na to, di ba? So, x tan theta minus 1 half gx squared over 2vi cosine theta I squared. So, ano ang pag-derive mo for? If we try to calculate the y ba, the x direction niya ba, or our velocity initial or the angle, no? So, at any point, so, mao na siya ang equation nga to ang gamiton. Okay? Now, let's have a sample problem number 1. A stone is thrown from the top of a building upward at an angle of 30 degrees to the horizontal with an initial speed of 20 meter per second. So the height from which the stone is thrown is 45 meters above the ground. How long does it take the stone to reach the ground? Here, we have this illustration, no? So uh, we have this ball here, no? Nakaposition siya at 45 meters above the building, top of the building. That is 45 meters. So let us say that our coordinate system ato i-point from asa sila i-thrown. So we have y and x here. So gi-thrown siya at the velocity of 20 meter per second, di ba? At the angle of 30 degrees. So mo ni ang illustration nga ato nabuhat. Okay? So how we will calculate the time that this ball, no, will reach the ground at let us say at point here, dito, no? So unsa yang time? Okay, so using our three kinematic tools of equation, we have y that is equals to vit, by, byit, so in terms of y direction, minus 1 half gt squared. Okay, now our y final here is, since ito ang coordinate system naka-point man dire at the top of the building, so nag-negative 45 meters yan, no? So that is equal to 0 plus 20. So our velocity component at y direction, that is 20 sine 30 times time minus 1 half gt squared. So our time is, that is equal to 4.2152 seconds. So now siya pag-calculate, no? Kung kuha na to, how long does it take mo reach siya sa kaning ground. So that is for sample problem number 1. So sample problem number 2, a sky jumper, the sky truck moving in the horizontal direction with a speed of 25 meter per second. So the landing incline below here falls off with a slope of 35 degrees. So where does she land on the incline? So how pila daw yang ano measurement this d, no? If maka-land na siya from this slope ni nga slope nga, for example, this one is the mountain nga slope or incline falls. So what distance, no, nga ma-fall siya diri dapita this point? Okay, so we have slope that is 35 degrees. Okay, so the initial velocity here is 25 meter per second. Okay, let us say this one is our coordinate system, no? Or the point of origin ng to i-analyze. Okay, so we know that our velocity, this one is in terms of horizontal direction. So we have this velocity, no? At padong diri nga orientation for our velocity, that is in terms of horizontal direction, 25 meter per second. That is equal to our distance. So our distance here in terms of x direction, so that is d cosine, that is our x, no? D cosine theta over time. So Vx is equals to x over t. Okay. So now we have also this equation, no? Y equals to Vit minus 1 half gt squared. Okay. So to calculate the y here, that is negative d sine 35. So since wala man tay uh, wala man tay in terms of incline or slope na velocity, no? So this one is ma-cancel out, di ba? Kay ato ang velocity dire in terms of horizontal direction raman. So ato ang formula na lang is ang may bilin is equal to negative 1 half g t squared, where our t is equals to d cosine theta over 25 squared. Okay? So now in terms, ang variable nato is in terms of d na. So uh, our value for our d, where this man or woman day, she land on the incline, is equal to 108.92. So to calculate the y, that is negative 108.92 sine 35 or equal to negative 62.47. For x, we have 108.92 times the cosine 35. That is equal to 89.2. Okay. So that is for the topic of projectile motion. And for next chapter or next section, we will talk about uniform circular motion. Okay. So that is all for now. Thank you for your listening and have a good day.